Hello, good morning. I am Eduardo Saelo Canu. I am a student of Electrical Engineering of Instituto Tecnológico de Chetumal. It's my last year there, and I am research about materials. Well, my research topic is about ab-initio study of antiperovskite lithium 1-X iron 3 sulfur and oxygen for energy storages. Lithium batteries have had a great relevance in our times due to the fact the energy storage is of great interest, and it's thanks to these demands that the so-called solid-state limited battery have been chosen, where solid-state electrolytes were also used. In this work, we will analyze the structural, optical, and electronic properties of lithium tape with lithium with the structure our structure antiperovskite in the crystal structure using first principle calculation. Theoretical analysis of this material are not yet available in the literature. Thus, the experimental results reported previously will be complemented. My methodology its use was made of the PN2K computational package within the density functional theory (DFT) calculation, the Beck and Johnson potential modified by Transenblaha was used. In addition, until cells were performed for lithium 3 sulfur and oxygen. The other structure is iron 3 sulfur and oxygen, and with the structure we dopate with iron is lithium 2 iron sulfur and oxygen, and lithium iron 2 sulfur and oxygen. Finally, a supercell approach was used for the lithium iron 5 sulfur 2 oxygen 2 compounds. Our lithium 3 sulfur and oxygen perovskite has a lattice parameter and atomic position of AC equals 7.39 Armstrong and B equals 14.79 Armstrong. The space group is PM3M, and the structure is closer to a simple cubic structure. My results in this series of graphs, we can observe the results obtained from the computational calculation of our structure in the first graph. In the band structure in which we observe the density of state DOS of the lithium 3s sulfur and oxygen material that show the appearance of new energy levels or state as it gradually changed from lithium to iron atoms. That indicates that the incorporation of iron atoms in the material introduced new energy levels in the electronic structure. The following graph are the variation of the absorption coefficient as a function of the electrovolts of the lithium 3SO material. The graph indicates that the lithium 3SO material has a low absorption. The graph indicates that the lithium 3SO material has a low absorption capacity until it reaches 7 electronvolt, while iron 3SO has a higher absorption capacity. The figure presents the transmittance of this same material, and it can be noticed that this transmittance decrease as one gradually changes from lithium to iron atoms. The decrease in the transmittance could be related to the forbidden band of the material. The last figure is the electron density. The electron density indicates the probability of finding an electron in the area. On the contrary, in the image, we can visualize the lithium atoms with sulfur. There is very little interaction, so we can say that to the range of this temperature has partial covalent bond. In conclusion, that gradual change of lithium atoms by iron in the structure lithium 3 sulfur and oxygen material can have a significant impact on its optical properties, density of the state, and potential application in battery. Well, this is my presentation. Thank you so much, and thank you for your attention.